I'm looking down. In any case, it doesn't matter. As I said, we got ahead of schedule. How did that happen?
I have no clue.
You know what? I know what happened. Is the people that own and organize the show actually listen to me, because I used to say the sessions are too close together. We need a little space between them, and they gave us space this year, and we got ahead of schedule.
So what I can do is try to keep us on schedule once we get rolling.
Okay. Are you good, or are we still?
We're close. So we're getting. We have a little PowerPoint problem here, but so.
Okay. I'll let you take over.
Yeah, absolutely. So just so I can get an introduction, my name's Steve Connor. I work for a company called Cloudistics, and I'm going to spend a little bit of time going over public cloud. We all know about that. So I am going to ask a couple of questions to get this started, because I like to have a little interaction. And then I'll walk you through some of the ideas that we've seen to date in cloud, but some of the things we've also given up as we've gone through this process, and potentially some ways we can get those back, some of the give backs that we've taken when we've gone to the public cloud. So we'll get the presentation going, but before that starts, and we'll skip a slide when we go in here, who in the room, show of hands, is either has a cloud-first plan, strategy, has moved to the cloud, or is planning to do something in the cloud? And I should see pretty much every hand in the room go up. Wow, not every hand. That's kind of crazy, and the lights are in my eye, but I saw a lot of hands. So you guys you're moving there, and if you didn't raise your hand, your boss is probably thinking about it anyway, right? It's going to be part of the deal as we're going through. So that's the first slide we have. I just want to see how many people are actually, are the clickers enabled? How many people are actually doing the cloud? Because at the end of the day, there's a lot of benefits to that process, going out to the cloud, and I won't kid you, there are a lot of use cases that make complete sense in going to an Amazon or Azure or something like that. But the cloud is not necessarily all things to all people, right? When we look at the cloud, we have different providers. These guys, I think these guys are cloud providers. We know all these guys. Pretty much all the hands that went up are probably using one of these guys. When we look at these guys are cloud providers too, if you just look at the base definitions, right? And I'll walk through those in a few minutes. We're probably using those too. I can tell you that I am actually using a couple of those myself today. And then lastly, these guys are cloud providers too. So you've got SAP out there that's providing cloud services, Splunk as well. They're heavily invested in this today. So when we talk about cloud, when you guys are looking at this, what is a cloud provider? That's a big question. So we have to talk about that and think about it as we go through. When we look at cloud and how we've gotten here, I'm going to walk through a couple salient characteristics in just a few minutes, but a lot of people say they're going to the cloud. So all those hands that went up, how many people have said to their boss or said to their spouses or peers, we're going to the cloud? That is the message you got. And there's got to be a few hands that go up for you. We're going to the cloud. All right. And those that you didn't raise your hands, you're not being honest. Come on. You're going to the cloud. So it's not really a destination, right? I mean, going to Amazon is not a destination. It's truly a journey. I mean, we don't necessarily just go to Amazon because it's cool. We don't go to Amazon because that's what our boss told us to do. We go there as part of a business process. So what generally happens is IT can't meet needs. And I'm going to talk about what I see as a vendor, the 4 horsemen of the cloud, in just a few minutes. But the 4 horsemen, and it's bad for me. But when we look at IT needs, a lot of times when we start this journey, we can't meet the expectations of what our people want. And this is usually the application developers or application owners. So what happens is our friend, the CXO, says, we're going to the cloud. So we're going there. We're going to do this, guys. And he puts the mandate that every single workload in every single system in your IT shop is going to be in Amazon in 18 months. So, and I've actually had partners of mine that have made that mandate happen. Not make it happen, but have made the mandate go down. So we get that edict from the boss, and we go, oh my God, what am I going to do next? So we start thinking about, what does that actually mean? So we had all of those cloud providers up there, Amazon, Azure, so on and so forth. We actually have to look at what's going on. And I talked about workloads when we first started the conversation. This is going to talk, and you're going to start thinking in workloads. If you're not thinking in workloads, you're making some big mistakes, and we'll talk about that in a few minutes. But the team analyzes the capabilities. Microsoft Office 365 does one thing and one thing well. It provides you Office products, right? Amazon does a lot of things well, depending on what you want to do. If you want to host virtual machines, cool, you go to EC2. If you want to do a lot of development things inside of Amazon, you've got a lot of tools available to you, but you have to analyze what's going on out there. Then we get into the dreaded CapEx and OpEx conversation, right? How am I going to ultimately save money? Because this is what the boss is actually looking for. He's either looking to make things faster or he's looking to make things cheaper. So we're going to do the CapEx, OpEx conversation, and then we're going to do the big TCO analysis. Now, as we go through this, I'll give you some examples. Cloud isn't cheaper. A lot of people, when they get into cloud, think, oh, it's going to be cheaper. It's like leasing a car. Leasing a car is never cheaper. It's more convenient, but it's never cheaper. So they do the TCO analysis and work their way through that. Then they start going, okay, now I can start thinking about workloads. And this is where the magic starts to happen. You start thinking, wow, I can actually start thinking about moving my Exchange server and services out. I can start moving certain development capabilities out, and that makes complete sense. Once you've done that, you start doing your ROI analysis, and this is where the real magic happens. TCO, kind of cool, a little boring. ROI is actually where you're going to make a lot of bang for your buck because you're going to actually see what that project will do for you in the long run. And then lastly, once you've done all that, we're starting to think like cloud people. We're no longer thinking about going to the cloud. We're not going to Amazon anymore. We're actually going to think about what it means to take this journey and always be analyzing. Some people, an example of one of my customers is a bank in Canada, and they have done a lot of analysis. And they said that it's time to decloud. They put a lot of things up in Amazon and a couple other cloud providers, and they've made the decision to move back on-prem. And that was predominantly done for costs. So I promised you the horsemen. So when we look at cloud and how cloud works, there are 4 factors that drove us here. First is speed. When the developers started looking at Amazon, they wanted to do things quickly. Now, there's probably a lot of people in IT, and you guys can throw rocks at me a little bit later, but generally, we are slow. We can't get things set up quickly because the architectures are just not designed to do it. So when we have a developer that says, I'm now running an agile development cycles, and I need to spin these things out in 2 weeks, waiting for an IT person to spin up a virtual machine that takes 6 weeks, not going to quite fit into the development cycle, right? So they're going to go, Amazon, $20, I'm in, virtual machine spun. Next, we look at control. As a developer or as an application owner, there's a lot of value going into control, right? And you laugh at the horsemen. I picked the horsemen for a reason because these guys are dangerous for a vendor. But control, the developer wants to have control of his own destiny. So by going to an Amazon or an Azure or someplace else, they actually take that control back. This is where Shadow IT was born, these 2 things. Now, the other one is simplicity. I don't know, how many people have actually deployed an Amazon instance? There should be a decent number of hands. Pretty simple. My wife has done it. And she's not an IT person. It's easy to do these things. I mean, when you go to Office 365, credit card, download, done. It's pretty simple to do. And for a developer, he or she does not want to be playing around with switches and storage and computers and virtualization and all that stuff. They want to spin up something and make it run. And then the last thing is cost. Now, we will visit 2 of these horsemen again. Amazon, to start with, is cheap when you get into the first portion of the instance. Now, maintaining that long time, not necessarily. But when you look at the cost of a vCPU in Amazon or Azure or Google, it's pennies. So when you're analyzing that and you see pennies are pennies. I can get in for pretty cheap, right? So in the mind, you start thinking about, can I do this on cheap? And I absolutely can. It's pennies. Now, that's not always the case. And these horsemen are what drove us to the cloud. This is what made people go, we're going to the cloud. So this is how we got here. Now, when we look at the cloud, and this is going to drive us to how we can get the principles back, some of the things that we can do to take the good things of the cloud and bring them back into our control. There's 5 salient characteristics. These come from NIST. They're also been, if you do the analysis of any cloud architecture out there, they fit. The first thing is it's self-service. Every single cloud provider out there, including Splunk and SAP, you can go out and stand up your instances on your own, regardless of who you are. Now, you might need to be a little bit more technical on the SAP side, but you can do it on your own. So that's number 1. You got to be self-service. Number 2, broad access. Everybody who's in the cloud has broad access to it, right? And that basically means networking access, but more importantly, access to the components such that they're pretty easy to work with. When I go out to Amazon, I don't think about what I'm doing. I just do things, and things under the cover happen for me. So that's kind of what I look at as network broad access, and then the simplicity of using the actual components. The third thing are shared resources. Now, this is tough for almost any IT shop, especially if you're trying to do things from a departmental standpoint. This is, for anybody who's a service provider in the audience, this is the dreaded multi-tenancy conversation. This is where most of us fail. So in order to be a cloud provider, Microsoft doesn't set up an instance of of Exchange for each one of us. They share a lot of resources. So this is key to making the cloud, quote unquote, cheap. The next thing is elasticity. I can go out and do any of these things and spin them up and down. Now, up is easy, down not so much. So we're going to talk about some ways to look at down as we go through this. And then the last thing, measured and metered. So who in here has ever asked for the two, either the C word or the S word, charge back or show back? There's going to be a lot of you, so don't be shy. I mean, I'm going to see hands. Everybody's asked for it. Heck, I've asked for it, right? Charge back and show back. What these guys do well is being able to show you your metered usage, right? So these are the things that every single one of those cloud providers that I put up on the first slide do. This is the core foundation of what they do. So architectures. We've got some good ones out there, right? But they're not quite there, right? When you look at this guy, it's clunky. I mean, it's kind of, there's a lot of things going on there, right? And it's tough to be simple. It's tough to be agile. It's tough to share resources in here, right? And this is a standard stack that we've deployed forever. I can admit that I've sold this and I've actually set this up. So it's a great stack, but it's not cloud. This stack is getting better, right? It's a pretty decent stack, but it has a couple of idiosyncrasies that don't allow it to be cloud. First and foremost, that broad access, that network component, it's not there. It's not shared, it's not managed, and it's not something that's ultimately controlled by that footprint. So when we look at that, we've disconnected from the standard Amazon instance that we would see, because we have to deal with networking there. And then because we've got disjunct components, there's a lot of management there. So it's close, right? We smush things, but it's not quite to where we need it from a cloud standpoint. And when we look at these things, and we've gone to the cloud, what have we given up? This is where I'm going to bring a couple of the horsemen back. When we look at the cloud, we've given up control. So when I talk about control, the developers got some control back, but we, as IT professionals, lost control. The shadow IT thing is real. When you look at what Gartner says about shadow IT, billions, just in the United States, are being spent in shadow IT. So that's with the big B, billions. And that's the control we've lost to the cloud. And that's because it's easy to take that credit card out of your pocket and do what you need to do. Flexibility. Now, this is an interesting topic here. If anybody has built or developed an application and tried to jam it into one of the public cloud providers, they sell things in T-shirt sizes. So if my application doesn't fit into that T-shirt, I either have to buy bigger or I have to jam it into the size. So it doesn't have the right flexibility you'd expect to see as an application developer. So this is a problem. I mean, is it easy to get in? Yeah, but is it quite what I want? No. Security. So is Amazon secure? Maybe. I think it is, because it's the most attacked platform in the planet. But here's the problem, and I always use a lot of analogies. It is a public swimming pool. It's well chlorinated. You know the water's pretty clean, but you don't know what your buddy next to you is doing, or this buddy next to you is doing, right? So you have the guy over here that's chair surfing, and he's going to hit you pretty hard maybe. Or you got the guy over here who's got his rubber duckies out, maybe not so bad, but they're doing things around you that can ultimately impact you. Amazon's cool, but if you're using those cloud providers, they do not guarantee your security. They guarantee the security of the platform. When you look at the experience, if you're using a user-based application that requires heavy experience, like VDI, or you're trying to transmit data like Splunk to the cloud, a lot of people lose the sight of the fact that, dude, my mouse is like 10,000 miles away now. It's hard for that mouse to interact. Or I got to get 10 terabytes of Splunk into Amazon. How the heck's that going to happen? I got to put some pretty big pipes up there for that to happen. So the experience drops off when you can potentially drop off when you look at this. And then cost. The other horseman's back. So this horseman basically is when you leave something on 24/7, which is most of our applications, 70% according to Gartner, those costs run up. So if you look at a standard C4 extra large instance from Amazon on a 720-hour clock, it will cost you just a little under $300 a month. Multiply that by 10, you're now at $3,000. Multiply that by 100, you're at $30,000 a month. That's just for the instance, not for storage or any other attributes that go along with it. So if you start doing that times 12, times 36, your ROI conversation just got washed out the door, right? So we got to pay attention to these things. And these are the things that we trade off when we go back from those infrastructures that I just showed on the last slide and move to the new ones, to the cloud architectures. So how do I get all this stuff? I'm a pretty big guy. I like to have my cake and eat it too. So I want to do this with infrastructure too, right? So how do I get these things? I want the horsemen, but I also want to not lose these things. And there's ways to do this. Technology is advancing to a point where we can actually do this. So the answer is composable infrastructure. Who out here has heard of hyperconverged? Raise your hands. I know you've all heard of it because it's in the news, right? This is the next iteration according to Gartner. And this is pretty interesting in the way it works. So as we walk the stack and how we got here, we walked that traditional footprint, right? It was the first siloed infrastructure circa 1990, right? That's where we all were standing up our minis and our, our first client server footprints. And that was cool. Converged was our FlexPods and VBlocks. Clunky, that was the first picture to the left. Hyperconverged are our SimpliVities, our Nutanixes, our VX Rails and so forth. And now composable, first coined by HP, thank you HP, is an environment where everything is software defined. Everything, including the networking, but it's interlocked as well. And what this does is it gives us back the salient characteristics that we need to be a cloud on-prem. So let's walk through those feature sets, right? So what makes a platform composable? First, it's got to be end-to-end integrated. Amazon is end-to-end integrated. Azure is end-to-end integrated. So you can't leave any pieces stranded. So if you want to have a platform like this, it has to address all of the components: networking, storage, compute, and virtualization, because almost everything, I think 92% according to Gartner, of the workloads in the United States are virtualized. So it's got to be end-to-end. You have to have resource pools. Now this is key. When we do things in the cloud, we don't think about, oh, I got to have it sitting here or sitting here or sitting here on that specific machine. We go, I need some of this. So I need this type of resource, I need this type of resource, and they have to be federated. You have to have the ability to just say, I'm going to put this thing here and it's going to consume. You have to have everything software defined. So everything in the cloud is software defined. Amazon doesn't have a whole bunch of clunky machines, and Azure doesn't have a whole bunch of clunky machines. You guys have all seen the pictures of the cool guy rolling down on the Segway, taking things out of the data center. That's what software defined does for you, and they do it at every level. It has to have integrated microservices. So this is a little bit more techy, but what this does is allows us to have the ability to take what would be concrete service, a switch or a VLAN, and take that and make it a microservice, something that's not necessarily predicated on hardware. You have to have self-service capabilities. We talked about that in the beginning. It's one of the 5 salient characteristics. You have to have end-to-end integrated security, because you want your pool chlorinated as well. And then lastly, you have to have the ability to address this via API. So this is the definition according to Gartner. This is the definition according to my friends at HP. And this is the definition that I subscribe to for composable. So I'll stop, let everybody take a picture for a couple seconds. And you guys can pick this off of pretty much the internet. That's where I got it. So this framework, I'm gonna walk you through how this actually works for real. Everybody good? Pictures good? Awesome. So what do we do? How do we get there? So we got to have hardware, right? But at the end of the day, who really cares about the hardware? It's got to be fully integrated, fully automated, all that good stuff. And it is a platform, because we're going to bring this back on-prem. This is the opportunity to say, that workload, I think it was good in Amazon, like my banking friends, but I made a mistake. I want to bring it back on-prem. But I want to get all the horsemen and all those things I gave up. So we're going to look at that. So it's fully integrated. We talked about that. The next thing is that this platform is going to have all these characteristics. So I'm going to spend a couple minutes talking about this. In this environment, Software-defined is cool. We've all heard of software-defined networking. We've all heard about software-defined data center, software-defined storage. In this environment, that doesn't mean that you're going to have saliently disjuncted in things associated with those particular environments. These have to interlock. So the networking infrastructure has to work simultaneously with the computing infrastructure. They have to interlock. And that computing infrastructure has to work interlocking with the storage infrastructure. So they all have to interlock. So when we say software-defined everything, this is a term that's starting to matriculate out in Gartner's world. They mean fully interlocking. And you cannot get an Amazon footprint on-prem without full interlocking software-defined everything. To get the pools that you have to have independent scaling. One of the downsides of the hyperconverged footprints that we saw was that they lock everything together. Simplified things, dramatically simplified things. But what happens when you lock three resources together is they trail each other. So if I've got one that's constraining me, the other two get locked or stranded and they just drift on forever. In order to make this so that you can scale it up and down, because remember we talked about that, scaling up and down, I have to unlock that constraint. So in order for this to happen, I have to make things independent of one another. Switch ports are independent of computers, and computers are independent of storage. So that's what Amazon does as well. When you look at those pools, we talk about it. They're federated. They're spread out across everything. So they, just like the hyperconverged footprints, we want to spread those resources out. So when you go to deploy a system, an application, a virtual machine, you don't say, put that on system number 2. I'm an older guy, so that would have been named Yoda when I set that up. Put it on Yoda. That's not the way it works. I just say deploy virtual machine, deploy application server, and it goes out and consumes resources. Microsegmentation, we touched. Pretty much everybody in the room probably understands that. And then the last thing that we get in is this self-oriented management system, single pane of glass. For those guys that raised your hands, thank you very much. For having deployed an Amazon instance, you don't have to do anything but go to the Amazon pane and start deploying things, right? EC2 instance, EBS, I can do virtual load balancers. All that's done in one single pane of glass. And it's self-service, right? In this footprint, it's capable of doing everything that you need to do from that single footprint. And then the last thing, in order to be cloud-like, and I didn't have this on the last slide, it has to be self-healing. So you can't go, oh, dude, that broke, and it just broke. It took my cloud down. That's bad. So you have to have the ability to have components in that environment, from my point of view, that are all self-healing. They've got to be able to self-update, and they've got to be able to self-heal. And self-updating is scary, but a lot of people are starting to get used to the self-update. Anybody who's in Amazon right now, you're self-updating. Amazon doesn't tell us, oh, I've done an update. It just happens. So it's out there. So we are getting used to this idea, and you can do this on-prem. Oh, pictures. People need pictures? I saw cameras. So I'll come back to this, or you guys, I think you can get the slides. So salient characteristics, we're back again, right? So when we look at these things, self-service, these 3 buckets that we talked about create self-service, microsegmentation, SaaS portal, and self-healing. It gives you the ability to create that self-service. The key thing there is the actual SaaS-oriented management capability. It is the key to making this self-service. When we look at broad access, the segmentation in SaaS help, but here where the software-defined everything makes it such that everybody can get to it, right? So I have full access from a management standpoint, but it's also fully segmented and I can get access to everything. When we look at shared resources, this is the biggie, the multi-tenancy piece, right? That we were never able to do in those clunkier architectures. Because everything's software-defined, because I have micro-segmentation, and because everything is federated, I can now carve my resources up independently of one another. And the cool thing is, when I carve them up, I don't have to worry about my neighbor. There's no longer that guy chair surfing in the pool next to me. Those resources are dedicated to that particular tenant or that particular division, and you can actually report on it. This is where some of the metering happens. When you look at elasticity, the independent scaling capabilities are where that helps, right? So when I'm looking at being able to scale up and down, I have the ability to have, incremental units, and then the federated resource pool capabilities give me the ability to actually remove things. Now, we've had that ability for a while. I used to work as a NetApp partner. I could take things away from a NetApp filer. Not easily, but I could do it, right? In this environment, when you look at that from a takeaway standpoint, it's a simple click. You say, I want to move this resource from here to here. The federation takes care of a lot of that. And because it's fully integrated, I can do this at will. And then lastly, the measured and metered, the charge back and show back. Because these things are partitioned, because I can put them in virtual data centers or whatever term you want to call them, I can give people control of being able to see what they're using. So now I can go back to business A and say, hey, look, I assigned you all these resources. I've given you these application capabilities, these virtual machines. I'm going to charge you for them. And because I have this SaaS portal that actually reports on all that stuff, it gives me the ability to say, and oh, by the way, it's this much per each type of resource. So in this environment, in an environment where you're using composable footprints, getting the reporting out because of the tenancy capabilities is actually there. So we've gotten to the point where we can actually do real charge back and show back with these architectures. So with the platform itself, getting back to all salient characteristics, by having all these things there, you get to the point where you can have these salient characteristics on-prem. So that's an important thing. This is how we get to having the ability to take those 4 horsemen that we talked about and actually taking the things that we lost by going to the cloud and couple them back into a single platform. So what does that mean? So with my last few minutes with you guys, and I think I'm keeping us on track, we can, by doing this, by going to an on-prem cloud basis using composable infrastructure, you have the ability to take the horsemen back. You can give your developers the ability to have full speed, control, simplicity, and cost of their environments. Give it to them. It's self-service, right? Set up a VDC and let them do what they want to do. This will give you the ability to also get out of the business of worrying about those water flow, agile development cycles, because they're going to be in charge of it themselves. Let them go bananas. I would not let them manage networks, by the way. They're not very good there. And then, by taking this approach, you can also get these things back, right? So now we have control back. I have the infrastructure in my arms for the use cases that it makes sense. Flexibility, who cares how big it is? I'm gonna let the developers and the business owners manage that. I can make the exact thing that I need, fit the exact application footprint that I need. Security, it's on-prem. I mean, it's pretty much easy to say that, we're assuming, I'm making a rudimentary assumption that your infrastructure, your location is secure. So if we can make that rudimentary assumption, make that leap that you guys are good at handling your own security, then it's secure. If you're not, it is what it is. The experience is going to be on-premise. So VDI actually works now, right? No more distance-based mouse slides. If you're doing Splunk or big data, I don't have to worry about transmitting large pieces of data across a giant pipe. I actually have the ability to bring that experience back into an envelope that doesn't have issues with latency and distance. And then lastly, cost. When we look at these platforms, and we can help with these analysis, when we look at Amazon specifically, and then I pick on them a lot. This is a great architecture, by the way. I love Amazon. But when we look at Amazon specifically, you can take an architecture like this and decrease your overall operating costs, not any funny money around labor or anything like that, by 70% using on-demand instances. If you do reserved instances, for everybody that knows Amazon well, at the 3-year clip, fully dedicated, you can decrease it by 40%. So getting all of this back from a cost standpoint, you can actually do a lot better than Amazon. And because it's so easy to work with, certain workloads, why would you go there? So the net of this is, just to sum it up, if your workloads, we're on the journey, if your workloads are not meant to be in Amazon or Azure or Office 365 or any one of those clouds we talked about, then you do have the ability to think about options. And they're not, clunky, older architectures that we saw in the early 2000 timeframes. They have the ability to give you the horsemen and give you all the things that you gave up by going to the cloud. And as you go through your time here at the Cloud Expo, if you have any questions, you guys can feel free to come over and talk with us. Our group is well into this. It's a pretty new area, but it's an interesting area. So I would welcome you guys to come chat and ask any questions you want about composable footprints. And hopefully that was a good use of your time. So I thank you for your time.
Yeah, it was. Go ahead. Yeah.